Hi everyone, and welcome to Minerva Tutors TV, and today's lesson, how to build and launch your own rocket, which will be led by one of Minerva's top science tutors, Jack. So Jack normally spends his time providing after-school support and homeschooling to kids of all ages all over London. But today he's taking a break and he's going to take us on a scientific adventure. So first things first, safety. All experiments are, by their nature, capable of going wrong and producing unexpected consequences, so we have to take this seriously. Never perform chemical experiments when you're on your own, and always be under the supervision of a responsible adult. Always follow the instructions carefully and completely. Don't cut any corners or vary measurements. Always think safety first. Just be cautious, use good common sense, everything will be fine. In particular, if you spill anything, clear it up straight away, and if it gets on your hands, wash them really thoroughly before you touch your face or eyes. So be careful, be sensible, and be safe. If you've got everything on the equipment list and an adult supervising you, you can follow along and construct your rocket live with Jack. If not, you can just learn the process and do it later. So that's all from me for now. Have fun, and here's Jack.
Thank you very much for that introduction, Lawrence. As he said, I am a science tutor at Minerva. My name is Jack, and today we're going to be hoping to do quite an exciting experiment where we're trying to prove that rocket science isn't as difficult as it's made out to be. So the first question, whenever we would do working with rockets and talking about rockets, is what are rockets and why do we need them? Why do we use them? I'm sure you've all seen rockets in movies, rockets in TV programs, and maybe even on the news, or maybe even you've been lucky enough to see them in person. But what do we actually use them for? So one of the main reasons we use them is to send astronauts to space. And so we send astronauts to space for several reasons. One of the main ones is just to answer questions that scientists are asking. So that could be things like, what's it like in space? That's one of the most simple ones. One of the more challenging ones would be, what's the composition of the soil like on a certain planet, or something along those lines. Another reason why we send rockets up would be to send supplies to the International Space Station. So the International Space Station is orbiting the Earth right now, with several astronauts on it who need daily supplies like food, toothpaste, all the supplies that we would need in day-to-day life. But obviously they can't just go to the shop if they're in space. Another use that we use rockets for are to send satellites up to orbit around Earth. And those satellites allow for us to have communications like we're having now over internet, cell phone communications, send TV signals around the world, things like that. Rockets themselves, they're a particularly interesting form of transport because they're one of the only ones that actually defy gravity. Before we talk about how exactly they do that, we need to talk about what gravity is. So gravity itself is a force that was first theorized and first come up with the idea of gravity by a man called Sir Isaac Newton. And the tale goes that Sir Isaac Newton, a scientist at the time, was sitting underneath an apple tree, and an apple fell and landed on his head. And with that gave him the thought of, what made that apple fall on my head? What made it come towards Earth rather than float off into space? So he put together this idea of gravity. That gravity is something that pulls two objects together. And so that could be a tennis ball and another tennis ball. There's going to be some sort of gravity pulling them together. Although you won't really see it with things as small as tennis balls. It only comes into effect with huge objects like the Earth. So the Earth, because of it's got such a great mass, it has an even bigger gravity than something like a tennis ball will have. So everything on Earth tends to drop down towards the ground, like the apple that fell on Newton's head, instead of floating off into space. So this is something that rockets have to overcome. And it's a question that ever since we were early cavemen and we first had the conscious thought and were able to sort of stand upright and think straight, we've been thinking about ways of how we can defy gravity. We've seen the birds flying in the sky and with their hollow bones, and we've been wondering how we can do that and achieve that. And throughout history, there's been sort of quite a few myths and legends of people who have tried to be able to fly. So one popular one is the Greek myth of Icarus. So Icarus is, the myth goes that he was a boy who really, really wanted to fly, and his father wanted to make this wish come true. So he made him some wings out of feathers, out of wax, so that he was then able to fly. Unfortunately, Icarus learned about the dangers of gravity from this. When the wax between the feathers melted, his wings fell apart and he fell down to the ground as well. If we fast forward through time from Greek mythology to about 100 years ago, we have the first aeroplane. And the first aeroplane itself was created by two brothers, the Wright brothers, Wilbur and Orville Wright. And as you can see, it doesn't look like the planes we have today. It looks a little bit more dangerous, and it was. In fact, this plane was only able to fly for about 12 seconds before it came crashing down. But it was the first time that humans were able to successfully fly and able to experience what the birds are experiencing. If we flash forward from that point about another 54 years, we have the first commercial flights taking place quite regularly. So now people are able to fly for much longer than 12 seconds and fly further distances and to other countries around the world. Around this time as well, we had the first rockets starting to set off, and the first rocket going and taking a satellite into space was around this time as well. So we not only were we able to have better airplanes, but also we've got the first rockets. So we're defying that force of gravity even more here. Moving forward to the present day, since then we've had a man land on the moon, of course, and we've done many trips to the moon to orbit it, which is just to move around the moon, and also to a few more successful trips to land on the moon as well. So that's another feat we've done using rockets. And more recently, we've landed rovers on Mars, which have then gone on to explore what the soil composition, the atmosphere is like in Mars, and send that data back to Earth, so we can now learn more about other planets in our solar system. So that's examples of how we're defying gravity with these rockets and the reasons why we're wanting to use these rockets to defy gravity. So we'll talk a little bit about more how a rocket works now itself. So it doesn't work like these commercial planes that we might regularly go on, because what they have is, as you can see with this one, it's got turbines underneath the wings. So they work by drawing air through these turbines and forcing it out the back end of the turbine, propelling the plane forward. What that means is that it's using air in the atmosphere to propel it forward. Now, a rocket, it could do this as it was lifting off the ground. It could do this as it's traveling through the atmosphere. But once it gets to space, a rocket has to work a little bit differently because there's no air in space. It's a vacuum. That's what we mean when we say space is a vacuum. It means there's no air in there to be pulled through a turbine and propelled out the other side. So we have to come up with a different way of propelling something through the sky when we're talking about rockets. And the way we do that is to burn rocket fuel, which could be hydrogen gas, it could be a sort of like petrol-like substance, but we're burning that, and out the back of the rocket or out the bottom of the rocket is coming these fumes from the burning of it. And those fumes are what are pushing it off of the ground, pushing it through the air and defying the Earth's gravity, and then continuing to propel it throughout space. So you can see how it's working a little bit differently to the jet engines there. And a good way to sort of imagine how it's working in space is to imagine that you're stood on a skateboard. And that skateboard itself is able to move. And in your hands, you've got a basketball. And if you were to propel the basketball out of your hands forwards with a bit of speed, not just dropping it, but with a bit of pace, if you propel it forwards, what you're doing is not only are you pushing the basketball away from you, but you should feel yourself move backwards on the skateboard as well, because the basketball is actually pushing against you as you push it. So that's the physics rule or law of every action has an equal and opposite reaction. So that if you're pushing something one way, it's pushing you back the other way. So this is being shown by the skateboard being pushed by the basketball backwards as well. And when we're talking about a rocket in space, not only is the rocket pushing the fumes away from itself, but the fumes are pushing the rocket away from itself. So what that allows the rocket to do is, even in space where there's no air, move apart from the fumes and move forward through space. So it's a very, very interesting technology, rockets, and it's a problem that they've had to solve and couldn't just use the plane engines that they already had for. So that's sort of how the rocket fuel works. But our rocket fuel today isn't going to be quite like that, because if I was to set you up for filling a bottle with rocket fuel and igniting it, I'd have a pretty hefty lawsuit on my hands, I think. So we're going to be using something a little bit less dangerous than rocket fuel and igniting that. We're going to be using vinegar and baking soda. So this will still produce some sort of fumes. The rockets that we were just talking about then, they produce carbon dioxide, and that's the fumes that are pushing it through. We will still be producing that carbon dioxide to propel our rocket upwards through the air. But we'll be creating it in a little bit of a safer way. So what I've got here is I've got some vinegar, and this vinegar is an acid. Because it's an acid, it's on something that we call the pH scale. So a lot of chemicals can be separated into three categories: acids, alkalis, and neutral solutions. So on the pH scale, as you can see here, the red and the orange and the yellow on the side furthest away from me, they're your acids on one side of it. On the other side, we've got the blues and purples and even the dark greens, which will be your alkali solutions. In the middle, we've got neutral solutions. Now, neutral solutions are things like water and salt, the things that they're very they're very, like if we think of water, it's very tasteless, it's very boring, really, if you think about that. Whereas if we think of acids, acids tend to be, you tend to be able to tell what an acid is by its smell, and that it is an acid, because if you smell the vinegar you've got now, you can smell that it tends to be quite sour and quite bitter, and that's representative of a lot of acids. So some of the other ones we can see up there on the scale are lemon juice as well, which again is quite bitter. Fruit juice will be quite bitter occasionally as well. On the other side, we've got our alkalis, and the alkali we're using today is baking soda. Baking soda, bicarbonate of soda, sodium bicarbonate, whatever you want to call it, all the same thing. It's an alkali. And what happens when we mix this alkali with an acid is, because they're on two different sides of the pH scale, this scale that we can see up here, when we mix the two together, they react together and neutralize each other. So by neutralizing, they're meeting in the middle of this scale and meeting in the neutral zone, where they're producing things like water, things like salt. And of course, in this reaction, it gives off a gas that is carbon dioxide. So let's take a look at that. So what I'm going to do, there's no need to do this now, you'll get a chance to do this with your rocket fuel a bit later. I'm going to pour about a teaspoon of the baking soda, and I'm going to pour it into my acid. And what we should see with this is we should see a gas starting to be produced, and you can see it's starting to fizz, it's starting to foam, it's rising and rising and rising and rising, and that is the carbon dioxide gas that's being released. Very much like what we would have if we were working with a real rocket, very much like the fumes that are coming out of that. So with that reaction, it's all very, very well and good doing it in here, but that's not going to fuel a rocket, simply because the carbon dioxide is escaping. It's escaping, and as you saw, it didn't propel the glass anywhere, because it was just escaping into the atmosphere or the air around the glass and getting out. When we're looking at our bottle rocket, what we're going to be doing is doing this reaction inside it, so it's and corking the bottom. What that provides is an enclosed area, meaning that as this carbon dioxide gas is being produced, it's filling up this bottle and filling up this bottle. and it's increasing the pressure of the bottle. And the reason it's increasing the pressure of the bottle is if we look at what we're actually starting with, we're starting with vinegar, which is a liquid, and we're starting with baking soda, which is a solid. And if we look at how the particles are arranged in those two things, we've got the solid baking soda here. The particles are very, very close together. We've got the liquid vinegar here as well. Again, the particles are very, very close together. But as soon as it turns into a gas, which is the carbon dioxide, the particles are much more spread out. And what that's meaning in terms of our bottle is if those particles that were close together in the vinegar and baking soda, if they are being mixed together to form this gas and the particles are being more spread out, it means there's less room per particle. One way to think about it is if we were in a room with a lot of other people and everyone in that room was wearing deflated sumo suits, as soon as we react the two things together and we start turning the vinegar and baking soda into carbon dioxide, it's kind of like we're inflating those sumo suits up, inflating them up and causing there to be less room in that room of people until eventually, if you keep inflating them and keep inflating them, the room's going to burst. And that's exactly what's going on with our rocket here. So we're inflating the bottle more and more and more and more until eventually what we would hope to happen is the cork to fly up the bottom and propel the rocket upwards through the air. So that's what we're hoping to happen with our rocket today. Very, very much like the expanding particles, and the particles taking up more space, are very much like sumo wrestler suits, expanding and expanding and expanding. So we're going to talk a little bit about how we're designing our rocket now. So the first thing with designing our rocket that we want to work on is we want to attach a good base that it can stand on. So to do that, we're going to take our 3 pencils, pens, sticks, whatever we've got, and kind of make a tripod around the bottle. So I'll try and give you plenty of time to do that now. And I'll do it as we go along, but you want to use your tape to attach them. So I'll attach the first one and sort of show you how I'm doing it. But you want it taped nice and securely on, and you want to tape it so that it's overlapping the end of the bottle there. So you can see, because when we stand it up, what we're hoping is there to be a bit of a gap between the cap of the bottle, the opening of the bottle, and the ground, so that your cork or your stopper, whatever you've got in there, has room to fly out. And you want to make sure it's nice and securely taped so that when we're doing the experiment, it doesn't sort of topple over either. So nice and securely taped on there. So once you've got one on, you then want to estimate where you're going to put the third one. So the second one. So we're putting the second one, not on the exact opposite side, but near enough on the opposite side. So you can see what we're aiming is when we've got all 3 on, it to make kind of like a triangle if you were to join them up. So you can see a bit like that. We want it to look something like that. So we can tape our other 2 on to try and evenly spread them out around the bottle to make a tripod that will stand it up. Now for this, you can use 4 if you wanted to, if you've got an extra one and you wanted it to make it more stable, but 3 should be enough to keep your bottle stood up. And again, I'm just making sure that I'm securely taping the legs on this bottle rocket here. So I've got 2 on, just going to do the third one now. Yeah, because the reason you want to make it very, very secure, just because even if it is a bit windy outside when you go to do it, then it shouldn't fall over. If it does fall over, the important thing is just to leave it until it blows up or the cork comes out. It probably won't go in there. It might skid along the ground. So just watch out for that. But the important thing is to leave it and let it do its thing rather than going to try and pick it back up, because you'll end up with vinegar and baking soda all over yourself. So I've managed to put the legs on now, and I'm just going to test if it will stand up, and it will. If yours doesn't stand up at this point, it will normally be because one of the legs is slightly too long. So you'll want to take that one off and retape it so you've kind of got them all about level. So that when it stands up, it's not too wonky, and you can't. It's quite challenging to push it over. So once we've got this, we've got our base of the rocket here. And if you haven't had enough time to do that, don't worry, you'll have plenty of time to do it at the end of the lesson. And the next thing we want to do is we want to come up with some sort of a design for our rockets. So we want to draw the rocket shape, and rockets tend to have quite a bit of a point at the top. So I'm going to start by drawing that out. And the reason that they tend to be quite pointy is to make them what we call aerodynamic. So this means when it's leaving the Earth's gravity and launching off of the ground, it can cut through the air really, really well. Other things that are aerodynamic are things like arrows, because we want those to fly through the air really, really well. Even planes, you'll always see the nose of the plane comes to a bit of a point as well to try and cut through the air, like so, and it just helps it go faster, helps it be more efficient with its fuel. So what I've done here is I've drawn out a very, very basic rocket. This first one only has to be very, very basic. As we can see, we've got the cone of the rocket on the top. We've got a window for the astronaut at the top, and I've just written Minerva space across it there. So once you've got your very, very basic design, and after the lesson as well, feel free to make some that are a bit more complex, a bit more, maybe you can make something that looks along the lines of this here. So with this one, I've just raided my kitchen to see what I can find to put things together. I've given it a cone made out of tinfoil, sort of a tinfoil coating. I've stuck a bottle cap on the front and painted over that. We've got some toilet rolls stuck to the side. So you can be really creative with it when you're making your next one. But this one's just the first initial test one to give you an idea of what's going to happen. As you can see, I've used a bit of a bigger bottle here as well, and I've used silver pens for that one. So you can really be really creative with it, and if you do end up making one a bit like that, or you want to show us the one you made in the lesson, do get in touch and let us know what you've made. But so we've got our design, we've got our bottle with the legs on it. All we're going to do with our design is sort of wrap it around the bottle and stick it in place with a piece of tape. And then that's again just so you might like to even just not do a design first and just see the bottle, so you can see the reaction happening inside. It's completely up to you. Great. So once we've made our bottle, what we need is we need to make our rocket fuel. We need to get the fuel to fuel the rocket. We know we're using the vinegar and we're using the baking soda, but as you saw with that reaction that we just did, it happens very, very quickly. So we want a method that's going to slow down the amount of time it takes to do that reaction, or for that reaction to happen. And so what I've come up with is we can keep the vinegar the same. We can't really change that too much, but what we can do is we can put the baking soda, and we'll want about a tablespoon of baking soda. We can put it in and wrap it in tissue, because what this does, if I just pour some in the middle of here, again, you want about a tablespoon of baking soda. If we wrap this round in tissue, what it does is it creates a little bit of a time release system, if you like, where the baking soda doesn't come in contact with the vinegar straight away. There's a little bit of a pause, but while the vinegar goes through the tissue before it actually starts making the carbon dioxide. So it gives us enough time to get the cork on our bottle, and then turn it the right way up and take 3 big steps back before we launch it. So yeah, pretty nifty way that we can slow down that reaction and just give ourselves a bit more time.
Jack signed off for a second because he's going to move outside now to launch his rocket. He's going to launch his rocket, and we recommend that you maybe save your launch till later, because he's going to show you in detail how to do it safely and properly. So if you may have finished your rockets, you may not have done yet, but either way, I think if you just watch him really closely, he's going to go through the process, getting it all set up, getting the fuel into the bottle, getting it secured, getting it stable, and then getting to a safe distance. So you can do the launch yourselves later on under supervision.
Are we ready to start?
I think we are, yeah we are.
Yeah, super. Okay, so like I said, we're going to have our rocket here. And again, don't do this right now. You will have a chance to do this after this demonstration. So we've got our rocket here. And I've already poured out about half a cup of vinegar, as you can see here. And I've prepared my sort of fuel packages, we could say, down there as well. So I've also got a stopper. For a stopper, I'm actually using a bouncy ball, so it doesn't have to be a cork. It's just whatever fits in your bottle best, really. So what we'll do is I'll just sort of talk through a dry run of it. But the first thing you can do quite safely is pour the vinegar in to the bottle. And so we've got it, we've got about that much vinegar in the bottle, as you can see there. That's a good idea of how much we want in. Leave that like that. And what we're going to be doing, so I'll be taking one of these sodium bicarbonate packages and popping it in, then quickly putting the bung on top, forcing it in as best I can, spinning the rocket over, standing it up, and taking at least three big steps back, but you might want to take more depending on how enclosed your garden is, and just leaving it to do its business. And if it falls down, thing is not to drink up or anything like that. Let it fall down, let it explode. And I'm going to slowly try and lower this in here to start off. And I'll put the bung in afterwards with it. And if I spin it around, take three big steps back, and we can see what will happen. Thank you very much for joining me today, and I hope your rockets are as successful as that one was, and I hope you enjoyed this.
Thank you, Jack. That was absolutely fantastic. Your rocket went off amazingly. This is brilliant. I really enjoyed it. I hope all the pupils enjoyed it as well. Thanks everyone for tuning in. Don't forget all the safety precautions that Jack talked about, and having an adult with you when you do your launch, because as you can see it goes quite high, and make sure there's nothing above you for it to hit, like a ceiling or something. So definitely outside in the open space. For now though, Minerva Tutors TV Space Corps is signing off. I hope you'll have a great day. Goodbye from Jack, and goodbye from me.